All right, last section of this chapter is section 4.6, talking about congruence and overlapping triangles. If you want to pause and look at this again, we did find 31 different triangles in that picture there. Last week, we talked about how triangles are connected and what can we assume. So two triangles can be connected by a vertex, right? So if they're connected by a vertex, what can we assume?
They're triangles.
What can we assume if they're connected? These angles are congruent, okay? So we talked about that. We also talked if they're connected by a side length, okay? What can we assume by that middle side? It's congruent, right? Because if I were to split up those two triangles, they would still have that common side shared. So that is what we are used to seeing with these triangles. Now we're going to talk about even more overlap, just like we saw with the triangles on that image we were looking at. So what I want you to do is we are going to skip that next page there. Go ahead and flip to this page here that says overlapping triangle congruence.
I found it.
Okay? Yes. Okay? I outlined these notes a little bit differently here because this topic can get a little bit dicey. So I made the pictures a little bigger to look at. Okay? So first thing we're going to talk about with overlapping triangles is their common parts. Okay? Or where they overlap, what sides they share. Okay? So looking in this first picture here, it gives us a congruent statement. Okay, it wants us to find a common side. If it helps you and you want different colors to see the triangles, you can do that by drawing them and outlining them. So we are comparing this triangle with this triangle. What is the common side that they share? Side. ED. I agree, because if I were to pull those two triangles apart, they would still have this side in common. So I'm going to call that a congruent side. So their common side is ED. Could I call that side DE?
Yes.
I could, right? Yes. Okay. Looking at another way they can be overlapped is with a common angle. Okay, so again, if it helps to overlap these and outline them, I'm comparing this triangle with this triangle. What common angle do they share?
Q.
I agree with Q, but notice if I'm just looking at that red triangle, is this Q an angle? No. What angle do they share? It is angle M. Okay, so I can call that angle M congruent. So their common angle is M. Okay, these two ways here, a common side or a common angle, are the two ways that triangles can be overlapped in two ways that they can share. Okay, so by a common side or a common angle, we're going to often call those shared sides and shared angles as we move on. Okay, so what I want you to do on 1 through 3 in your groups is identify the common side or angle in each of those sets. Go. Again, if it helps to outline them, go ahead and outline them. But what is the shared item in number 1? It is angle H here. So again, I can call this angle H congruent to itself. So the shared angle is angle H. What about number 2? How are they connected? What is their shared side or angle? I think I heard VZ. It is VZ. Okay, this is a common side between the two triangles. So VZ. What about number 3? It is AC. Okay, do you agree we saw a bunch of triangles like that last week? Okay, these really aren't overlapped, okay, but they do share that common side with where they're connected. Okay? Questions about shared sides and shared angles? We'll see a lot more of those throughout today. Let's look at 4 through 6. Okay? It wants us to state how these two triangles can be congruent to each other. So notice how they already have congruent markings, okay? So it already told us on number 4 that this side is congruent to this side and that this angle is congruent to this angle. Is there anything else I can assume about those triangles? Why DE? Yeah, because that's where they overlap, right? That's the shared side. So why do I mark those with 2 lines? That's our new pair, right? That's the second pair. Okay, can I assume anything else? No, I can't, right? Can I just randomly assume that these two angles are the same? No, because they're not connected or they're not overlapped. Okay, so how can I say these two triangles are congruent to each other? How do I prove that?
Side angle
It's one of these, right? I can prove it with one of these theorems here. So matching that up, it is indeed side angle side. If you get lost in seeing that with how they're overlapped, go ahead and draw one of them out and label what we had. So we had this labeled. Do you agree that this shows side angle side? Yes. Okay, so if you struggle seeing it all together, go ahead and pull one of those triangles out and redo your markings to see what the pattern is there. Okay, go ahead and try the same process on number 5 and 6. All right, so notice in 5 and 6, they already have some congruent markings in there. Okay, we always want to see if we can assume anything else. So on number 5, can we assume anything else specifically with what they share or how they're connected?
Angle R.
It is angle R, okay, because that's where they overlap. So I can say that is a congruent angle. Okay, what does that match then? What theorem? It is angle side angle. Okay. What about number 6? What is the shared side or angle?
JN.
It is JN, so I can assume that side is congruent to itself. Okay, which theorem should I automatically check first? Hypotenuse leg, why?
Because that was right angle.
Because it has a right angle. Okay, so I know I need to check hypotenuse leg first. Does hypotenuse leg work? Yes. Okay, so this one is congruent by hypotenuse leg. This next page, now we are going to be talking about writing proofs. Okay, with this first page, we aren't going to be writing the proofs on our own. Okay, it already has some of it filled out. Okay, so we're going to kind of ease our way into the proofs here. So on number 7, that is in webbed form. Okay, number 8 here is in table form. Okay, number 8, that form, table form, we're going to use that the most. Okay, but I do want to show you what webbed form looks like. Okay, so let's go ahead and look at number 7 here. With proofs, it is always going to start by giving you a couple given statements. Okay, these given statements are things that you can assume. Okay, so it tells us given KF is equal to HG. It already has those marked for you, but you do always want to go ahead and mark those in your picture. Okay, so in our web here, or our proof, how did we know this statement was true? What was our reasoning for assuming that? It was given to us, right? That's the reason we could assume it. So our reasoning for this one is because it was given to us. Okay, the next part that they gave us is KG is congruent to HF. So I'm going to mark that in my picture there. What was the reasoning we could assume that? It was given to us. So again, given. Was there any other information given to us? No, those are the only two things that were given. So we're done with our given statements. Okay, once we have our given statements, okay, we want to look at our picture and see what we can assume. So again, looking for what they have in common, what can I assume with that picture? What do they have in common? Where do they overlap?
F and J.
F and G, right? FG, I can assume that side is congruent. Notice how it says that statement, right? FG is congruent to FG. Why could we assume that? Because it's the shared side, right? So that's our reasoning, shared side. Okay. Once we have our givens figured out and our shared side or angle figured out, we can then prove why these two triangles are congruent to each other. Okay, notice that this proof statement is always going to be the last part that you have to reason. Okay, so why are those two triangles congruent to each other? Side, side, side. Yep. Side, side, side. And then this one had it outlined for you, so once you have it all filled out, you know you are done. Okay, again, that's in webbed form. Let's look at it in table form, which we're going to see the most here. So, again, with proofs, what do we want to take notice of first? The given statement, okay? So it already has it outlined for you. Do you agree the reason of this here was because of the given statement? Did this come from the given statement? Yes, so our reason is given. And it does already have that marked for you. What about statement 2? How did we know that was true? Because it was given to us again. And it did have that marked already. Do we have any more given statements
No.
from the top here? No. For statement number 3, it says UY is congruent to UY. Why can we assume that is true? What's the reasoning? Shared side. Good. Okay, and then, again, whatever you're trying to prove, that's going to be your last statement that you have to reason. Okay, what is the reason that those two triangles are congruent to each other?
Side angle side.
It is side angle side. Yep, side angle side. Again, if you struggle to see that, draw one of the triangles out and label them individually. Okay, then you can see which theorem that matches. Side angle side. Okay. One more example that I want to look at before we get some more practice here is number 9. What form is number 9 in? It's in web form. Okay. Again, we're not going to see much of webbed form, but it is the same exact idea as the table form. Again, what do we always start with proofs? The given statements. So, were we given this statement here? Yes, so that our reasoning for that would be given, and it does have it marked for you already. What else was our given statement?
AB is congruent to A.
Yep, so we know this was given to us, and it is already marked there. Once we have gone through the given statements, what do we look for next? Where they overlap, right? Where they share. What do they share?
Angle A.
It is angle A. So angle A is congruent to itself. Okay, notice here that it labeled it with 3 letters. I do not care if you label it with 3 or label it with 1, but this does say the same thing as angle A is congruent to angle A. Again, why did we know that was true? Because it's the shared angle. Shared angle. Okay. How do we prove that two triangles are congruent to each other?
Side angle side.
It's with one of these theorems, right? This one's kind of tricky to see. I'm going to go ahead and draw this off to the side. Okay, here's one of the triangles that they see. This is how it's marked. What does that match? Angle, side angle. Yep. Are we done with the proof? No. Did we prove what we wanted to prove? No. What are we trying to prove here? That the angles are congruent, right? What does this automatically tell us? The triangles are congruent. So would our reasoning be for knowing those two angles are the same? The two triangles are congruent. Why can we assume that the other two angles are congruent?
That is a line AEF is congruent with B.
Right, you could assume that just because we know that these are the same, we know their corresponding angles are the same. But also, if we have proven that the two triangles are congruent already, we can assume all the other pieces are congruent because they are corresponding parts. Okay, so our reasoning for this one is because they are corresponding parts of the triangle here. So let me explain that a little better here. If I have the two triangles that we were talking about here. Okay, here's what was labeled. We said those were congruent, right? By angle, side angle. Correct?
Yes.
Okay, so can I then assume that this side would be congruent to this side? Could I assume that? Could I assume that this side is congruent to this side? Okay, and then can I assume this angle is congruent to this angle? Yes, the reason we could assume those things is because we already proved the two triangles were congruent to each other, so everything else is true because of corresponding parts. Okay? So once you have proven the triangles are congruent, that means everything else is true about those two triangles. Okay, what do you notice about the packet that I just handed out to you compared to what we've been working with? What'd you say? It's in table form. What else? Are any of the tables filled out? No, there's no parts of it filled out. Okay, I'm still going to ease our way into this. Okay, so I'm going to tell you how many statements there will be, and we're going to walk through how to fill the whole thing out. Okay, so on this first one here, we're trying to prove that two triangles are congruent to each other. So this one's only going to need 4 statements. Let's walk through how to get those 4 statements. What do we always start with? Given. Okay, so one given statement is that BE is congruent to DC. What's the reasoning for that? How do we know that's true? Because it was given to us. Okay. Is our picture marked? No. So you want to make sure you mark the picture with whatever information you have. So we know BE is congruent to DC. What would our second statement be?
Angle BCE is congruent to angle BEC.
Yeah, it's that other given statement. So we know angle DCE is congruent to angle BEC because why? It's given to us. Good. Do we have any more given statements? No. What do I also want to make sure I do with number 2? Mark it. Yep. So we have no more given statements. What do we look for after the given statements? Yeah, we see what we can assume, right? So look for the shared side or the shared angle. What do these 2 triangles share?
EC.
It is EC. How do I write that as a statement?
YEC is congruent to YBC.
Yep, EC is congruent to EC. What's the reasoning for that? Shared side. Good. Okay, just to answer some notation things, could I have labeled this CE as congruent to CE? Yes. Could I have put EC as congruent to CE? No. Remember, order matters. So if I write this, are C and E the same angle? No. So we got to make sure we keep consistent order with these statements here. Cool. We have one more statement to fill out. What was the thing we were trying to prove?
That triangle BEC is congruent to triangle BCE.
The triangles, right? So this proof statement is always going to be the last statement of the proof. Okay, so triangle BEC is congruent to triangle DCE. How do I prove that 2 triangles are congruent to each other?
Side angle side.
It's one of the theorems, right? And this one is, in fact, side angle side. Okay. And again, once you've proven the proof statement, you are done. I want you to try number 2 on your own. I will help you out here. We're trying to prove 2 triangles to be congruent, so you will have 4 statements. Go ahead and try number 2. So when it wants you to write a proof, what do you always start proofs with? Given statements. So our first given statement they gave us was BF is congruent to DF. Again, the reasoning is given. What do I want to do with that? Mark it in the picture. Yep. Again, whenever you make marks, it's kind of tricky with overlapping triangles. Okay, just know where when you mark things, specifically for this one, it's talking about this whole side. Okay, not just this little piece here. It's talking about that whole side. And then the other given information is angle B is congruent to angle D. Again, what's the reasoning? Given. What do we look for after the given statements? What we can assume, right? What can we assume on this one? I agree. This is our shared angle, so we can say angle F is congruent to angle F. What's our reasoning? Shared angle. Okay, and then finally, what goes in our last statement all the time? What you're trying to prove. So triangle BFC is congruent to triangle DFE. What did I forget to do?
Mark B and D.
Yep, I did forget to mark B and D. Anyway, how are these 2 triangles congruent to each other? Angle, side, angle. Okay. All right, last one I want you to do for today is number 3. Before you get started on number 3, do you notice anything different about number 3 compared to the ones we've done? Right, you're not proving 2 triangles to be congruent, you're proving 2 angles. But what do you have to prove in order to prove that? That the triangles are congruent. So how many statements do you think this one's going to have? This one is going to have 5. Yep. Remember, always start with your givens, and then the prove statement is always going to be last. Okay, go ahead and try that one. Again, how do we always start proofs? Given statements. So we know BF is congruent to DF. Again, remember how you mark them. Just remember what they mean. So those are for the whole sides there. What's the reasoning? Given, good. And then we know CF is congruent to EF. What's the reasoning there? Given. I want to make sure I mark that. Remember, that's just talking about the smaller side here. Okay, so this one might be better if you draw your triangle out separately. So what we have so far is these two here. Looking at our big picture, what do we do for our statement 3?
Angle F is congruent to angle F.
We want that shared angle, right? So we know angle F must be congruent to angle F. What's the reasoning?
Shared angle.
Shared angle. So what we just marked in our picture is this guy here. What's my statement 4?
Triangle BCF is congruent to triangle CF.
Yes. I'm going to pause here for a second. Does the order of this matter? Yes. So make sure this statement here matches what you had written first. How are those two triangles congruent to each other? What's the reasoning? Careful. It is side angle side. Yep. And again, if it helps, redraw it out here so you can see what the pattern is. And then what is my statement 5?
Angle D is congruent to angle B.
It's that proof statement, right? Why do we know, or why can we now assume that those two angles are congruent? Because they are corresponding parts. Okay, again, the reasoning for the reason of putting corresponding parts is because we already assumed or proved that the two triangles were congruent, so all the other corresponding parts must be the same. Okay?